Meet the Proxima Centauri. It's the closest star to our Sun and it's about 4.2 light years away. But it would take about 70,000 years to get there with our current technology. Luckily, we have solar sails. Solar sails are large reflective spacecraft that utilize light to push themselves forward. They have access to free, unlimited energy, light from the sun. You see, light is made up of particles called photons. They don't have mass or energy, but they do have momentum. As each photon bounces off the sail, its momentum gets transferred, giving it a little push. And since billions of photons are hitting the spacecraft every second, it accelerates. As it accelerates, it doesn't just aimlessly float around. Solar sails can actually adjust the angle of the sail in relativity to the sun, changing its course. There are actually three different types of sails: the square, heliogyro, and spinning disk. But let's start with the square sail. Oh, the square sail! The square sail is actually the most commonly used for space trips because they don't have hot spots. The sails protect the spacecraft from any thermal heat, and generally they create a higher force than others because of their high surface area. Meaning, because of their large surface area, they actually collect more photons, meaning they go faster and farther. And now for the heliogyro. The heliogyro is one of the only two sails that spin. It also doesn't have any actual sail, so it uses angular momentum to get around. It's lighter and changes directions by pitch and cycle. Think of it like a helicopter. And lastly, the spinning disk. This model can also spin. The only difference is that it has tiny gaps between each sail to help fully expand on the surface area. And it's also a circle. Now just how effective are solar sails? After being launched from a rocket, solar sails face no limits to space travel as long as there's light to push them. But let's keep it in our solar system for now. The sails would continuously get faster and reach speeds impossible for chemical rockets, which is, amazingly, 10% the speed of light, or 67,100,000 miles per hour. As the technology grows, there's a chance it could even reach 20% the speed of light. Now, I understand the numbers may be confusing, so let's put it into context, shall we? At the beginning of the video, I mentioned the Proxima Centauri, our closest star. Today, it would take us 70,000 plus years to reach it, but with solar sails, it could take about 20 years. Yeah, they're that fast. But how did we get here? I'm glad you asked, Sophia. And now, for a brief history lesson. Welcome to my class. It all starts in 1610. Yes, that long ago. Johannes Kepler theorized that comet tails must be pointing away from the sun because of the sun. And from that he speculated that solar radiation can act as a form of pressure. Now let's fast forward to the 1860s. James Clerk Maxwell released a theory called the theory of electromagneticism. He theorized that electromagnetic fields carry energy as well as momentum. Now they didn't mention the idea of solar sailing, but they did build the building blocks. It wasn't until the early 2000s that the idea of solar sailing started to really kick off. And now let's start with a few real-life projects, beginning with the Planetary Society and Cosmos 1. The Cosmos 1 was an 8-blade solar sail and was launched in June of 2005. It was set to use solar radiation to accelerate in space, but however, it didn't make it to orbit due to rocket failure. If it had successfully completed its mission, it would have been the first ever use of a solar sail in space. Now with JAXA, the Japan Aerospace Exploration Agency, and the IKAROS. IKAROS stands for Interplanetary Kite Craft Acceleration by Radiation of the Sun. But let's use the acronym. IKAROS was launched in 2010 and became the first solar sail to demonstrate that solar energy provides efficiency for interplanetary space travel. In that same year, it successfully flew by Venus, completing its space mission. And finally, the Planetary Society and the Light Sail. In addition to the Cosmos 1, the Planetary Society also launched 2 different light sails. The Light Sail 1 was launched in 2015, but it suffered a software malfunction while in space. This ultimately made it unable to send signals back to Earth, and eventually it descended back into the atmosphere. But the company didn't give up. In 2019, the Light Sail 2 was launched. They made improvements based on the errors with the first solar sail, and as of now, it's still flying in Earth's orbit. Let's end with a few key takeaways. Solar sails are these large reflective spacecrafts that use the momentum of light to move forward. And remember, there are 3 different kinds: the square sail, heliogyro, and spinning disk. They can travel up to 10% the speed of light and even make it up to their closest star in about 20 years. Early studies began in 1610 with the German astrologer Johannes Kepler. The Cosmos 1 was meant to be the first use of solar sails, but it failed to reach orbit. So that's that on solar sails. They still have tons of potential in space tech, and they may be the key to interplanetary travel. You never know when it comes to space.